All right, this is a skateboard park. This, by the way, is 2C. Skateboard park is a mound that is h meters high at a point where the horizontal distance from a fixed point P is x meters. All right, we don't have to really worry about any of that. It says the mound can be modeled by, excuse me, h is this. What's the maximum height? Well, to find the maximum height, we want to find the turning point of this. To find the turning point, number of ways we could do it. We could actually say minus b over 2a. That would be the x value of the turning point, yeah? And this itself is calculus. However, we're not going to do that. We're just going to go straight to this here, and we're going to use the differential of that. So if we differentiate h with respect to x, we end up with, well, 2 times negative a half is negative 1, or negative x in this case, plus 3. So in that case, if I make this equal to 0, which I need to because 0 is going to be the point where this has got a gradient of 0, so m is 0 at that point. That's 0, there it is, minus x plus 3, which means that x, so therefore x is equal to 3. So just in the same way as we could do this here, minus b, that's minus 3, all over 2 times minus a. Well, a in this case is going to be negative a half. That's 2 times negative 1/2. And that itself also equals negative 3 over negative 1, which equals 3. So you could do it like that, but this way here is what they're looking for. If you did this way here, you'd first prove that this, in fact, was the case. And you can do that quite easily using the general equation for a quadratic. So to do that, we would just say y is equal to ax squared plus bx plus c. We would differentiate this, go dy dx, which is 2ax plus b. We'd make this equal to 0, which is 0 is equal to 2ax plus b. We would subtract b from both sides. So we've got 2ax is equal to negative b. We would divide both sides by 2a. And x would be negative b on 2a. So you could do that first if you wanted. Oops, sorry, you can't see that last bit. Negative b on 2a, there's x. And you could, so you end up with this here. You could do that first if you wanted, and then substitute in the values for b and a respectively. However, we can do it this way probably more easily. So this would be a long cut. Most people would know this equation, but to know that, you'd have to show it because you would have to use calculus to do it. All right, so we've got our x value. There it is. Let's get rid of all this here. Make a bit of a gap here. It says, what's the maximum height? So now we will put the value of x back into the h equation. So h is equal to 0 point, or negative 0.5 times 3 squared plus 3 times 3 plus, oh, I'm running out of space here. I'm going to redo that, but okay, I'll do it with a sharper pencil so I can fit it in more easily. So I've got h is equal to negative 1/2 times x, which we decided was 3, square it, plus 3 times 3 minus 1.5. And if you go ahead and do all of that, you're going to get 3 squared is 9, half of 9 is, in this case, it's negative 4.5, plus 3 threes are 9, minus 1.5, and all of that there comes to 3. So the height is 3, and the value of x is 3. So effectively, the coordinate at the top here is 3, 3. But nonetheless, though, therefore, we can say height of mound equals 3. There are no units. 3 meters we'll put. Yeah, 3 meters. I'm going to say there are no units, but there are, in fact, units there. And that's what I would write. Hopefully all that makes sense.